Hello all, and welcome to The Good, the Bad, and the Meshy. My name is Joe Searcy, and I'll be your guide today as we talk through T-Mobile's journey of adopting Istio as our service mesh. Let me start by introducing myself a bit. I'm a technology enthusiast at heart, but I get paid money to be a staff engineer at T-Mobile with a specific focus around distributed systems and all things Kubernetes related. I've been working with the Kubernetes and Istio communities for a while now. I try to stay involved in the upstream communities in various ways. I'm also the maintainer of the open source MagTape project that focuses on Kubernetes policy as code. We're not here to just talk about me though. At T-Mobile, our platforms and services are the product of a team of rock stars. I'm just the one here talking about it today. So I want to take a moment to shout out to all the amazing folks that work with me to make all of what I'm about to cover possible. Now, before we jump into the service mesh story, let's do some quick coverage of where we were when we came to consider adopting service mesh technology. We have been doing the Kubernetes thing for a while. We started to get to the point that most people do where one cluster turns into 2, turns into 10, and so on. We still had a pretty diverse environment with other container platforms like Cloud Foundry and a lot of applications that didn't make sense to drive to Kubernetes from virtual machines and bare metal systems yet. Security was a big concern as our platform grew and new risk surfaces emerged. There was a definite learning curve in the container space for our developers, and we wanted to simplify that as much as possible. As with anything your business becomes to depend on, resiliency was a key focus in everything we did. Now, with any large project, we work down a list of goals to help us drive towards service mesh adoption. We had a very small team to start with, just 1 to 2 engineers. So we had to keep that in mind, and that forced us to automate everything from day one. We knew that service mesh wouldn't be a good fit for all users at first, nor were we really staffed to handle the support burden from our entire user base being forced to adopt it across the board. Since we wanted to make the service mesh a part of the platform, we didn't want to have Istio-specific clusters, and that meant we'd have to have mesh and non-mesh users co-located in the same clusters. We also knew we wouldn't be successful if we tried to tackle everything all at once. So we picked what we needed to prove that this service mesh thing would work and gave ourselves time to mature, both on the platform side of things and within our development organization. So now let's jump in and talk a little about how we Istio and what Istio looks like in our environment. We had already standardized on a GitOps model for driving our platform automation, and Istio was no exception. We built down a small abstraction layer that allows us to manage our platform components in a very flexible way. This gives us varying degrees of granularity for installation, configuration, and upgrades of the Istio control planes and gateways. We package our own internal releases from a combination of upstream Istio releases and our environment-specific configurations. And with this, we can pinpoint changes to specific clusters, entire regions, lifecycle environments, or the global fleet all at once. This model greatly simplifies the operational overhead of managing so many mesh instances with a small staff of engineers. We started our Istio journey before version 1.0, and let's just say it's been a wild ride. As with any complex software, you need a good plan for lifecycle management. Just getting it installed everywhere is not enough. The day 2 operational burden can be huge. This is part of the process where we learned a ton, as it was sort of a new model with respect to how things could impact consumers of the platform, with the data plane sort of being user-facing to some degree. To help ease a lot of this, we came up with a pretty formal process for promoting Istio changes and upgrades in our environment. There's no magic here. We started by reading the release notes and the change logs of upstream releases to see if there are any configuration changes or breaking changes we need to be aware of or solve for in our own config. Then we started installing the new release in a sandbox environment, and we execute our own suite of tests to validate things. We verify things through established functional tests that allow us to assess functionality against a known baseline. And in cases where we're adopting new features, we may have specific customer teams install an application specifically designed to take advantage of those and test those features. Eventually, once things have been burned in, we feel comfortable and we begin to promote things to the rest of the lifecycle environment until it's deployed everywhere. Overall, we're trying to build a high degree of confidence that as we deploy new releases, we don't break things. So moving on to the user experience, which has always been a concern, as we wanted to make the consumption of Istio as simple as possible for our platform customers. Today, each cluster is its own mesh. So yeah, over 100 meshes at the moment. At a high level, we try and absorb as much of the mesh complexity into the platform and tooling as possible. We have common ingress and egress gateways established in a centralized manner. For this, we have the load balancers, DNS, the TLS sort of pre-plumbed, so things just work and our mesh consumers don't have to worry about any of that. Users opt in to consuming the mesh via namespace labels, again, with the goal that mesh and non-mesh consumers can coexist without issues. Altogether, this helps to give mature development teams immediate access to service mesh features and also provides a clear runway for other teams to adopt over time. In addition to the common features most folks associate with Istio, we have also found a lot of use with regards to handling SNI routing for services. This takes the concept that most folks are used to with an ingress controller for HTTP services and makes it possible for TCP-based services that support SNI. We get the same one-to-many name-based routing functionality as an ingress controller instead of mapping node ports or burning through load balancers. Overall, we get a much higher degree of scalability, and this greatly simplifies operational overhead for things like database as a service type flows, where the clients that consume the databases live outside of the cluster where the databases are deployed to. Our service mesh story is far from over. We still have a lot that we want to do, but overall, we're down with the meshness. We started to play around with integrating non-Kubernetes services into the mesh, things like virtual machines. We're following along with the enhancements coming from the Istio project, but aren't far enough along to have developed any real opinions so far. Another one of the big things in our service mesh roadmap is moving to a multi-cluster mesh topology. While we're definitely solving problems with the multi-mesh topology we have today, overall, the more inclusive a mesh is, the more useful it can be. We want to target a heterogeneous mesh of meshes, if you will, that will allow us to maintain the resiliency of multiple control plane instances, integrate more non-Kubernetes platforms like virtual machines and bare metal systems, and hopefully simplify some operational burden over time. There's a lot of cool work going on in the community to help solve this sort of problem. In addition to the multitude of topology options and VM integration Istio offers now, there are things like the service mesh interface, or SMI, that provides a common way to configure mesh functionality. And also things like Solo.io's Glue Mesh and Glue Federation that sort of show this stuff in practice. So our Istio journey has not been all rainbows and unicorns. While I feel it's weird to talk about some negative stuff, it's valid to keep things honest. I think most folks will admit that Istio comes with a learning curve. Things have come a very long way since we started our journey, but not accounting for this in your own timelines is likely a mistake. There's been a lot of work over the past few releases focusing on stability, but it has been a real problem in the past. We keep a trust but verify attitude these days going into upgrades. And sort of tying into the release stability, we've seen default values change here and there, and in general, the API changes came fast and furious for a while. While most of the APIs are mature at this point, definitely pay attention to the release notes. We've been bitten more than once with things outside the mesh being invasive, some in slightly annoying ways and some in catastrophic ways. Don't have time to dive into full details of those right now, but feel free to follow up with me offline and I can share specifics about those scenarios. Releases come often. It can be really hard to keep up. The running joke we have is anytime we're in a meeting talking about a specific Istio release, there's probably a new Istio release being made. I wouldn't be surprised if a release was being cut during this presentation. Now, I want to take some time and share some of our lessons learned. I've tried to keep these focused on things that are not specific to our environment, but as usual, your mileage may vary and some of these things may not be applicable for you. We'll start by addressing some things around complexity. What I'm talking about here is complexity of Istio for both the implementation and the consumption. Many enterprises have a separation of duties around those who build and maintain the mesh layers and developers that consume it. Here are a few things to keep in mind that we found helpful. Do not let buzzwords or the fear of missing out drive your adoption. I know everybody likes to hear what's going on in the community and they don't want to be left out, but talk through your needs and lead by features that are important to you. It's also entirely okay if you're not ready or don't have a need for a service mesh yet. Next, finding real-world examples can be tough. I'm talking about things that take more into account than a demo install or a perfect world greenfield approach. The Book Info app is really cool and can definitely be helpful for learning, but it's best to spend the time to generate some easy to consume patterns with context to your business and your environment for your users to reference. And probably one of the biggest things I want to say to everyone is don't try and turn all the knobs on at once. Pick the features you're interested in, build a roadmap, and iterate over time. This will help prevent things from becoming overwhelming and reduce the risk of enabling something you don't fully understand or that could cause problems for your users or open you up to additional security risk. Next, let's talk a little about stability. And here I'm referring to maintaining a stable service mesh offering after you've got it deployed in your environment. The first thing, automation is your friend. The Istio project moves extremely fast and keeping up with upgrades can be hard. The more automated your lifecycle management is, the easier it will be to keep up. Set a realistic pace for yourself that works with your company's strategy. Skipping releases that solely implement new features or that may not be important to you is probably okay. Next, make sure you have a functional test for every mesh feature you adopt. It's easier to have the automation remember all the little things and verify that everything works than to have your people do it. This is also helpful when things change upstream and can allow you to catch those sort of things sooner rather than later. Now, if you do hit a snag or you find some sharp edges with the project that you didn't expect, codify that and add it to your automation. Trust me, you can spend hours or even days tracing down super weird problems. Make sure you don't waste your effort to find them and help yourself prevent them from creeping back up later. Now, if you stumble onto a problem and you do find a solution, please contribute that upstream. Even if it's just a sentence or two for the docs or opening an issue, this can be extremely helpful to the next person that comes along and is super valuable to the community. Next, let's take a brief moment to talk about usability. We saw a huge advantage in embedding our platform team with application development teams. This boundary is closing more and more every day, and decisions on how the mesh should be installed and configured need to be made with awareness of the applications in your environment. Meet with teams regularly to identify what does and does not work. Platform teams will rarely be able to anticipate everything that a development team will want to do with a service mesh. Next, let's talk a little bit about risk isolation. I want to reiterate that we have a mostly multi-tenant model for our Kubernetes platform, sometimes hundreds of teams and varying levels of mesh adoption within one cluster. That being said, as we're testing out how we want to handle our multi-cluster mesh strategy, we found that there's still a lot of edges that can come during upgrades, config changes, and environment-specific oddities. While the Istio project supports multiple topologies for how to tackle multi-cluster meshes, and some even offer more operational savings, for us, we're sticking with multiple control planes to reduce our overall risk of impact. On more than one occasion, we found that noisy neighbors can be a real problem. Within a mesh instance, we've had mesh users affect other mesh users across namespace boundaries, as well as non-mesh users affecting mesh users. The isolation boundaries are not very rigid right now, and this was, albeit possibly naive, a sort of surprise to us in the beginning. I'm happy to chat afterwards and provide some additional detail around these problems if there's interest. While the tenancy model for Istio is still maturing, we found it extremely helpful to have a policy as code tool to fill some of the gaps to limit our risk. We do use a tool built and open sourced by T-Mobile called MagTape. MagTape uses Open Policy Agent for its policy engine, but there are a ton of options out there like Gatekeeper, Kyverno, or KRail, just to name a few others. So to wrap things up a bit, let's talk about some wins we've experienced so far with Istio as our service mesh. I can't stress enough how big of an impact it can be to have generic observability instrumentation that can be immediately adopted by your users. This has provided an entirely new level of insight for our developers with zero effort, and from day one has been driving our mean time to recovery times down during events. We've been able to increase our security stature with many of the features that come out of the box with a service mesh like Istio. Moving from meaningless IPs to proper service identity for policy, auto-instrumented mutual TLS, and being able to generalize service-to-service authentication and authorization has brought in a huge decrease in engineering hours that are typically spent on solving these for every app individually. Being able to take a lot of the enhancements listed here and move them from the application to the sidecar has allowed our developers to get back to focusing on business logic rather than language-specific security, resiliency, and observability implementation details. This definitely helps bring down our cost per project by refocusing development efforts. Another sort of interesting side effect, and not something we initially planned, but we started building a shared competency in Envoy as a technology. The more we learn about Envoy, the more ways we find to utilize it within our environment as a sort of Swiss Army knife of data planes. And that's all, folks. I've enjoyed the opportunity to speak with you all today. If you have any questions about anything I presented, feel free to reach out on GitHub, the Istio Slack, or on Twitter.